In these series of lessons, we're going to review linear relations and straight line graphs. To start off with, we're going to look at the Cartesian plane. The Cartesian plane is formed by two number lines at right angle to one another. They intersect at a point called the origin. That's where both zeros line up. These two number lines are given names. The horizontal axis is called the x-axis, and the vertical axis is called the y-axis. You'll notice this infinite flat plane is broken into four quadrants. The first quadrant is here, where both the x and y values are positive. The second quadrant is here, where the x value is negative and the y value is positive. The third quadrant is in here, where both coordinates are negative. And the fourth quadrant is over here, where the x is positives and the y's are negative. Every point on this plane has a unique address. The convention is that we put the x value first and the y value second in brackets like this. Here we can see a point plotted. So this is the point P, which is represented by a capital letter, and its address is in brackets next to it. The x value is -1, so starting at the origin we move to -1, and the y value is -2, so we go down to -2, and we put a dot or a cross. It's important not to put the letter on that point, that we actually use a dot or a cross to show that point, and if we label the point, we put the label next to it. Here we can see some more points plotted. These xy points are called ordered pairs. Here is the point 2, 3, so we go across 2 and up 3. The coordinates of the origin are 0, 0. Here's the point -3, 1, so we go across to -3 on the x-axis and up to 1 on the y-axis. And of course you can have fractional points, there's no limitation, so we go across here to -1.5 and down to -2.5. The names for these are called the abscissa, which is the x value, the first number in the ordered pair, and the ordinate is the y value, or the second number in the ordered pair. It's important not to muck up the order of these. Some sets of ordered pairs will form straight lines when you plot them on the Cartesian plane, and these are called linear relationships. These sets of ordered pairs can be given as a table of values. If you notice that the x value is changing by a fixed amount for at least 3 values, and you notice the corresponding y values are also changing by another fixed amount, then the relationship is linear. Let's have a look how. Let's say we've got a table of values here for x's, and the x is changing by 1, starting at -1. Let's make up a value for y, say -2. So the first ordered pair is -1, -2. So we go across to -1 and down to -2. And we put a dot. That's the first point. Now let's imagine the y's are changing by a fixed amount. So let's say they're changing by +2. So -2 plus 2 is 0. 0 plus 2 is 2. Let's go ahead and plot those two extra points. The point 0, 0 is the origin, and the point 1, 2 go across 1 and up 2 lies here. You can see these points make a straight line. You can see there's the straight line they all lie on. Let's do another one using the same x values. We'll make up a y value to start off with. Let's say 5. This time let's make them change by -2. So 5 take 2 is 3, 3 take 2 is 1. X is -1 and y is 5. It will take us up to here. When x is 0, y is 3. When x is 1, y is 1. You can see these points lie in a straight line. And we can see that there. Now, although these straight lines I've drawn stop, they go on forever, and so this relationship actually could describe an infinite number of points in between. If I only wanted these points in the table, I would have to show them just as the dots I started off with. For a lot of the time though, a table of values can be described using a rule which relates x and y. Here's such a rule. Y equals 1 plus 2x. In other words, we're going to take each x value and double it and add 1 to it. So 0 times 2 is 0 plus 1 gives a y value of 1. Double the 1 gives us a 2 plus 1 gives us a y value of 3. Double the 2 gives us 4 plus 1 is 5. Double the 3 gives us 6 plus 1 is 7. And double the 4 gives us 8 plus 1 equals 9. Now we can plot these points on the Cartesian plane. Here only one quadrant is shown. Sometimes you think when you look at your textbook that there's only one quadrant, but in fact we saw before that the number lines go in both directions. So here the first point is 0, 1. The second point is across to x at 1 and up to y at 3. Notice the 3 isn't labelled, but it's in between. Go across to x equals 2, y equals 5. Across to x equals 3, y equals 7. Across to x equals 4, y equals 9. You may have noticed as I moved the cursor there, each time we went across one, we went up 2. Across one, went up 2. Across one, went up 2. Across one, and went up 2. And that's related to the fact that as x changes by a fixed amount, so does y. That's what describes a linear rule. And we'll learn more about that later. We need to be able to use your CAS calculator to show these linear graphs. Also, we need to know how to adjust the windows so we can see them better. And finally, we also want to be able to show and set up a table of values. So let's have a look at an example of the line y equals 10 plus 5x, and we want to restrict the window between x values -1 to 5 and y values -1 to 40. So that's that one here. And now on our calculator, when we open up a graphing, we don't have a y, it's replaced with f(1) of x. The 1 is just a subscript. We've seen this before. And now we type in the other part of the rule, which is 10 plus 5x. And then press enter. Now you'll notice that we can see our straight line. It's labelled. We can move that label around if we want, so we can see it more clearly. But it's not the window that we want. So what we do is we press menu and we select window and window settings. Now you can see we can set these x-axis here, x minimum. We want to set in this case to -1. X maximum we want to set to 5. I'm going to leave the scale on auto. We're going to do the same for the y minimum, which they want us to use -1, and the y maximum they want us to use 40. Okay, we'll leave the Y scale on auto and press OK. And there we see the straight line in the window we wanted. This is often important later on when we're using models, a straight line to model real events. Okay, so how do we show our table of values? We go into menu and we look for the option table, and this time we're going to go split screen table like that. Now, let's say we want to see the x values starting at -1, going up by 1. So what do we need to do there? So we have to adjust our table. At the moment, our x value starts at 1, gives us a y value of 15, 2, 20, 3, 25, and so on. So we're going to press menu again, and you can see that brings up an option for table and edit table settings. So again, we can tell our table where to start. We can start at any value we want. We're going to start at -1. And our table is going to go up by 1s. That's fine. And really that should be okay. So we're just going to go okay, and there's our table of values. So if we go back, we can see the -1 is there. When x is -1, y is 5. When x is 0, y is 10, and so on. If you notice, we can go back further than what we set the table up. So here x is -4, -10 is y.